Alright, so the next topic that we're covering is period and phase shifts of sine and cosine. So in the functions of the form y equals a times sine of bx and y equals a cosine of bx, the value of b is the number of cycles of the function in an interval between 0 and 2 pi. Okay. So that's the b. Okay. So the period of sine and cosine is 2 pi over b. When 0 is less than b is less than 1, the period of the function will be greater than 2 pi. So when your b is somewhere between the numbers 1 and 0, then it's going to make it, the period's going to stretch it, horizontal stretching. If b is greater than 1, then you're going to have a horizontal shrinking. Okay. So here it says use a dotted curve to graph y equals sine of x. Use a domain from 0 to 4 pi. And then graph the function. So just in case you don't remember, sine starts here at 0, 0, and then at pi over 2, it's 1, and then it comes back down. And so once you find the pattern, it makes it super simple. 2, 3, and then you kind of just connect your curves. Okay. Oh, supposed to use a dotted curve. Small eraser. Okay, there. Alright, so we already did part A. We used a dotted curve to make sine of x between 0 and 4 pi. So now it's telling us graph y equals sine of 1/2 times x. Okay, so if we take half of x and then b here is going to be 1/2. Okay, so here's 1/2. Now our period is going to be 2 pi divided by b. So 2 pi divided by 1/2. So if you take 2 and you divide it in 2 halves, you're going to have 4 pi. Okay, you can put that in your calculator if you want. And so then that means between 0 and 4 pi, we're going to have one cycle. Okay, so remember this is one cycle. From here to here is one cycle, and then it starts all over again, the same little pattern. So I'm going to do this exact same pattern here. So between 0 and 4 pi is going to be 2 pi. Okay. Between 0 and 2 pi, this is where our curve is going to go up. Okay, and then between 2 pi and 4 pi, this is where my curve is going to go down. And that's it. Alright, so let's try another one. This one says use a dotted curve to graph cosine of x between 0 and 2 pi. So 0, well, it says on me to go to 2 pi. That's weird. All right, so remember cosine starts right here using the same pattern that they all have. This is what our cosine function looks like. And then it's supposed to be a dotted, whoops. It's supposed to be a dotted curve, so I'm just going to make it into a dash curve. All right, so that's my cosine function. So now what we're going to do is we're going to take y equals 4 times cosine. So 4 times cosine, our b is going to be equal to 4. That means it's 2 pi over 4 is my period. And then 2 pi divided by 4 is going to be half a pi, so 1/2. Okay, so what that means is between here and here, it is going to complete one cycle, okay? One cycle is, for our cosine function, it's that little U shape, and then it starts over again, okay? So with our cosine, it starts at 1, and it ends at 1. Right in the middle, it goes all the way to the bottom, so it's going to look something like this. Yeah. And then we're going to continue that same pattern. It says to go all the way to 2 pi, so this is where we're going to stop. So from here squished in. Like we took the curve and we got the point and kind of squeezed it in. All right, the next one, it says determine the period of the following graph. Okay, so this time we had to find the period by the equation. Now we're going to find the period by the graph. Okay, so this one, if we notice, it starts right here. This is my cosine function. It goes down, it comes back up, and then it repeats itself again. So this one between 0 and pi over 2, it completed one full cycle. So the period here is going to be pi over 2. Okay, let's look at the next one. This one's going to be my sine function because it starts here at 0, 0. And then it comes up, goes down, then comes back here, and then that's where it stops. Okay, so this number, well, it doesn't stop, it continues, but it continues the exact same pattern. Okay, so that is pi over 2 also. All right, phase shift. So phase shift is a horizontal translation. So you can use it with either sine or cosine. Now, if you're subtracting a number, then that means that you're going to move that number to the right. Okay. If you're adding a number, then that means that you're going to have a horizontal shift, and you're going to move that number, whatever it is, to the left. Okay, so here it says use a dotted curve to graph sine of x. So I'm going to graph sine of x again. So sine starts here at 0, 0. It comes up, comes back down, back up, back down. And that's your sine function. Now this one says graph the function y equals sine of x plus pi over 4. So because it's plus pi over 4, plus means we're going to move to the left. Okay, it's kind of opposite with the x-axis translations. And then pi over 4 units, which here, if from here to here is half a pi, then that means that this is a quarter pi. So it's only 1 unit on the graph that we're going to move to the left. So I'm going to go ahead and take this point, I'm going to move it to the left 1. I take this point, I move it to the left 1. I take this point, I move it to the left 1. I take this point, move it to the left 1. I take this point, move it to the left 1. This point, I move it to the left 1. This point, I move it to the left 1. This one to the left, and then this one to the left. And then we just connect our dots. And so that's a translation of pi over 4 units to the left. All right, the next one here, it says use a dotted curve to graph cosine of x. So we're going to graph the parent function, and then we're going to translate it. So I'm going to go ahead. Cosine starts at 1. It comes down, back up, down, and back up. Oh, it's supposed to be dashed. All right, and then from here, we're going to go ahead and move it pi over 3 units. Let's see. And then since it's minus, we're going to move to the right, pi over 3. Okay, so based off of my graph, from here to here is pi. From here to here is pi. And so since it's pi over 3, we're going to cut this into 3 equal pieces. So this would be considered 1, 2, and 3 pieces. Okay. So if we're moving it pi over 3 pieces, then it's just 2 little units. So here I'm just going to put 2 units. Okay. Or 2 little boxes. So let me go ahead and erase this. And since we're moving to the right, I'm going to take every single point. So this is my point. I'm going to move it to the right 2. I take this point, I move it to the right 2. This point to the right 2. This point, I'm moving it to the right 2. This point to the right, that's 2 more. To the right 2. This one to the right 2. This point to the right 2. This point to the right 2. And I think that's it. So it starts here. And that's what it looks like when we move it to the right too. All right, this next one says use a dotted curve to graph y equals cosine of x, and then graph the function y equals 2 times cosine of x. Okay, so starting with cosine, I think this is a little bit of a review from yesterday. So we have our cosine. Our cosine starts at what? Comes down, back up, comes down, back up. All right, so that's our power function, and they want us to take that and multiply it times 2. So they want us to change the amplitude to 2. Okay, so then that means that instead of starting here at 1, it's going to start at 2. It still goes through the same number at 0, but then instead of going down to -1, it's going to go down to -2. And so the height of your waves are just a little bit taller. Our period's still the same. We didn't change it. It's still 2 pi, which means that from here all the way up to 2 pi, it completes 1 rotation before it starts the exact same pattern over again. So that's how we know it's 2 pi. All right, this next one says use a dotted curve y equals cosine of x. Well, I think it's supposed to say sine of x. Sorry. Sine of x. Use a domain between 0 and 4 pi. So we're going to graph this function 1/2 sine of 2 times x minus 1. So this is a little bit more complicated, just a little bit. So let's start off by doing sine. So sine starts here at 0, 0. It goes up, then comes back down. Let's just put it in there. I'm just going to make this as a dash line, and this is just kind of like a little blueprint of what we're going to do. It's like a little guide. So then this one says graph the function y equals 1/2 sine of 2 times x minus 1. Okay. So this minus 1 is going to move our graph down 1 unit. So if we were to move this down 1 unit, it kind of looks like this. Which it affects where our midline is, because our midline here is -1. Okay, because it goes through. This will put the graph in half. Okay. So here I'm going to put y equals -1. Now, it does affect our amplitude as well, because the amplitude here is 1/2. What? 1/2. So then that means for this graph, instead of coming up all the way 1 unit, it's only going to come up half the way. So it'll be like right here. 0, half the way. So it's a little bit flatter. Okay, so now that we've flattened it a little bit, the last thing that we have is the period. So the period is 2, well, it's not 2, it's 2 pi divided by 2. 2 pi, and then you divide it by whatever number is in here. Okay, if it's a negative number, you still divide it by whatever it would be as a positive. So 2 pi divided by 2 is just pi. So that means between here and here, it'll complete 1 rotation. So I'm going to take this graph that we made, and I'm going to go ahead and squeeze it in between there and there. Now it's still going to have an amplitude of 1/2. It's still going to be shifted kind of down. Oh, no, it's not writing. Oh. So that's what one cycle is going to look like between 0 and pi. And then it's just going to repeat itself again. It's going to go up just half a unit. It's still shifted down a little bit. And then there's a second cycle. And then we do it again. That's going to be a third cycle. And then we can squeeze in just one more cycle. I think that's it.